Hello, everyone. This is yours truly, Lady Emmanuel, going over the bell ringer from the 19th of this lovely love month. Okay. Here it says simplify the following expressions, meaning when you see monomial with the binomial, monomial, it's just telling you to use distributive property. So I'm going to write here use distributed property or apply it, whichever terminology you feel comfortable using. I put that gap there, distributed property. So basically all we're doing is using the distributed property to simplify this expression. So what I'm going to do, I'm going to take the 3 and I'm distributing to each term within the parentheses. So this becomes 3 times x, and this is a positive, that's a negative, minus 3 times 4. So now the last step is just to simplify using multiplication. 3 times x is just 3x, minus 3 times 4 is 12. I'm done. You're done. You cannot combine those because those are not like term. This is an x term and that's a constant. So you're done. Number 2. It says here 3x times quantity, x plus 4. Take the 3x, distribute it to each term within the parenthesis. So you're going to say 3x times x. Those both are positive. 3x is positive, plus 4 is positive. So you can say plus 3x times 4. Okay? Here we're doing multiplication and we have an x and an x. This coefficient is 1, so 3 times 1 is just 3. The base here is x and x is multiplication. The form write x, and since we're multiplying with the same base, I add the exponent 1 here and 1 there, which we don't usually write. So 1 plus 1 is 2. Therefore, that's 3x squared. Bring your plus down. So I have this term simplified. Now my second term, I have here 3x times 4. I just have one x over here while I'm multiplying, so I just write x. Then I'm going to say 3 times 4 and write that product 12. So I have an x squared term and an x term, meaning they're not the same. So I leave it in standard form like it is. So I'm done. Okay. That right there was your lovely number 2 for that bell ringer. Going to number 3. Same process, applying the distributive property. So I take 3x squared, distribute it to each term within the parentheses. So I have here 3x squared times x, okay? Then I have here, that's a negative and this a positive, so that'll be a negative. Positive times negative is positive. So I have here 3x squared times 4. Okay? So now I have 3 and I have no other constant here besides the one which we don't write, so just write 3. So I got x squared times x. Now remember, this is multiplication. So x squared times x is the same as saying x squared is x times x. Bring that times down, bring that x. So I have x times x, which is x raised to the 3rd power because I have 1, 2, 3x. Therefore, the exponent is 3. The base is x because my factors are x. They're all x. So when I come back over here, I got x squared times x, which is x cubed. So I put x to the 3rd power. Here I have a negative 3/4. I have negative 3/4, and that's like I got negative 3 here, and that times 4. So that's what I'm multiplying, okay? So I have here negative 3 times 4, which is negative 12. Then I have just the x squared, and I'm done. Because I cannot bind an x cubed term with the x squared with addition or subtraction, so you leave it. Next is the 4th one. The 4th problem, 3x to the 3rd times x, 3x to the 3rd times positive 4. So I write 3x to the 3rd times x plus 3x to the 3rd times 4. Okay? Just like here, we did x squared times x is x to the 3rd. So here, x to the 3rd times x, which is to the power 1, will be x to the 4th. Okay? The coefficient for this x cubed is a 3, so I put 3 in front. So I have 3x to the 4th, because 3 times 1 is 3. Okay? Because the coefficient here is a 1, we don't write 1s. Plus 3 times 4 is 12. This just has an x cubed in this term, so I just write x to the 3rd. Okay? And now when I say terms, I'm referring to the information that's on either side of the addition or subtraction sign. So X is a term here, 4 is a term. Okay, X is a term here, negative 4 is a term here. So when it's split with addition or subtraction, these are considered terms. Okay, so this right here is a collection of monomials, which are my terms here. So this is our bell ringer that we did on the 19th of this month. Okay, thank you guys. I just want to share that with you to make sure you understand it, so you can go over the bell ringer to make sure. Although I went over the class, but it's the way that you can go over it again and again and again. Yours truly, none other than Lady Emmanuel. Love you guys. Nothing but love for you. Oh, that is awesome. I love my babies.